Hello. In our previous video, we took a detailed look at erythrocytes and their vital role in oxygen transport. But blood is much more than just red cells. Today, we are moving on to the next essential component of the blood, platelets. Despite their tiny size, these invisible lifesavers perform tasks that are critical for survival. And how do they sense a blood vessel injury? Let's find out how they work and what makes them so unique. Like erythrocytes, they are born in the red bone marrow, but their origin is unique. They originate from the same hemopoietic stem cell. After a specialized differentiation process, they develop into megakaryocytes. These are giant bone marrow cells that extend long cytoplasmic protrusions into blood vessels and shed platelets directly into the circulation. How does a platelet look? In its resting state, it's a calm, smooth disc, passively circulating like a tiny lens in the bloodstream. But don't let that piece fool you. The second a blood vessel wall tears, the calm, drifting discs instantly transform. They become activated star-shaped soldiers. Platelets deploy long, sticky tentacles called pseudopodia or fallopia. These are biological grappling hooks. Under normal conditions, the vessel wall actively tells platelets to stay calm, releasing chemical signals like nitric oxide and prostacyclin that keep them smooth and inactive. The moment that wall is torn, the signal disappears, and something far more urgent takes its place. Collagen is exposed. Von Willebrand factor floods the area, released from the damaged wall and the platelet's own internal storage to act as molecular glue. Platelet surface receptors recognize these danger signals within milliseconds, triggering an immediate localized response. When a vessel is injured, platelets anchor to damaged vessel edges. To amplify the response, they secrete active substances into the surrounding environment. This triggers a massive reaction where millions of platelets aggregate and interlock. Ultimately, together, they form a physical plug, the primary hemostatic barrier, sealing the injury instantly. Activated platelets aggregate, binding to each other via fibrinogen bridges. At this point, receptors on platelet surface grab fibrinogen, locking platelets together. As a result, the growing mass forms the primary platelet plug. And in the meantime, simultaneously, the coagulation cascade is triggered, reinforcing the plug with fibrin. Platelets press together so tightly and contract so hard using their internal proteins, actin and myosin, that their individual membranes can partially fuse. They transform into a solid mass, the plug. Moving to the final cleanup. As the biological repair reaches its conclusion, the body must safely remove the temporary blockade. Vessel wall heals as platelets gradually break down, releasing their grip on the site. Simultaneously, the molecular cleanup begins. Plasmin dissolves the clot after repair is complete. Today, we learned a little more about platelets in the blood of animals and humans. So the next time we look at a simple blood sample or manage a patient in a clinic, we are looking at a beautifully orchestrated, millions of years old defense system, working flawlessly at the microscopic level to keep life moving forward. Thank you very much for your attention, and see you in the next videos.